Hi there. Let's get started with chapter 1. Let's talk about blueprints. Why do we need them? What are they about? Well, we need to know that blueprints are an idea or a way to express an idea, to be able to say, this is what I want built. And to be able to do that, we have a common language among blueprints. Now they're not all the same, but like in our own common language, we all have different accents. We might use different words a little bit differently, but we have a same basic premise to how we communicate. And in blueprints, that's what we're going to be doing here for this first semester, first and second semester. We're going to start with some basic stuff on how to read them. What we need to know, just like when we're learning a language, is where do we begin? Like we're learning how to read or write. We need to know how to pick up a book and which end is up. We're going to start with that today. We're going to start with this very first page here. I want you to follow along with me if you can. The calculations and ideas of the engineer must be transferred to the welder working in the shop or on a job site. Essentially, that's the nuts and bolts of it. The engineer has an idea, says this is what I want built. And he'll say this is how I want it built. And he's going to have that information on there. It's going to tell you what it is, what's this widget, what's it made of. We need to know if it's mild steel, stainless steel. We need to know how it's joined. We need to know how many parts we're looking at. We need to know how big it is. So we need to know dimensions, right? We're going to need to know what our tolerances, what our build tolerances are. We're going to need to know what the scale is. Scale is going to be pretty important to what we're starting out with. We'll start with something easy. We'll start with like a 1-to-1, a true scale, and maybe do like a 1-to-2 half scale. And maybe if we need to enlarge something, we'll go to 2-to-1. But we'll start off with we're going to start with some small stuff. We're going to get to our first project for this week. It's going to be this. This one's pretty simple. If you've never seen one before, don't let this scare you. We're going to go through what's what. Now again, these prints are going to vary from one business to the next, and they're going to vary even from between what your company looks like, what your customer looks like, what your vendors' blueprints are going to look like. But they're going to have some same basic stuff. There are 3 basic elements to be found on a print: lines, dimensions, and notes. Lines show the edges of an object, aid in dimensioning the object, and are used in the formation of symbols. Dimensions give the lines and locations. Notes, giving details of construction not shown by lines, may be in the form of symbols or abbreviation. A print consists of 1 or more views, usually the top, front, and right side views of the object. And that's where we want to go next. We want to be able to start with some of the basic stuff. And it isn't the lines so much as it is the views. For basic views, drawings are made to describe the object in sufficient detail to permit fabrication. Orthographic projection is the method employed to do this. In this case, 3 views are used. That's what we're going to talk about here, these views here. In this case, 3 views are used to describe the object. Note that the views have a definite arrangement. We're talking this one here. The top view is placed directly above and in line with the front view. The right side view is placed to the right of it and in line with the front view. This arrangement of views is in accordance with third angle orthographic projection referred to in Figure 1.1. Simple parts can be completely described with only 1 or 2 views. Now it's these views that we're interested in. This is an orthographic projection here. What we're looking at is a front, a right, a top side. That's going to be your basic stuff right there. The front, the top, and the right. You can have other views, being left to the bottom, or go to the back side, and you can see I've seen different instances where a back side is off to the left also. But we're just interested in these 3 views right here and what they represent. And see, we have a pictorial representation, and I wanted to be able to put something together. So I went and I rated my son's Legos to give me something I can hang on to. So what the idea here is that we're showing is that we're starting with the front. And we're going to call this the front. We're going to pick this one. This profile. The profile selected for front view is generally that which best describes the most detailed shape of an object. So we're going to call this the front. Okay. And if we want to be able to look at it sort of like this, we want to be able to have as few views as possible to give us an idea of what we're looking at. So we're looking at a front, and then we're going to move it to the side like this. We're going to call this the right side. If we want to see the top, we go back here to the front and back to the top. Okay. Instructor Ben Boffman in the second year group, he likes to figure it like you're looking at something in a bowl and you're moving it around inside the bowl. So if we're calling this the front and we're calling that the right, we go back to the front. We got to the top. Okay, you're with me now? And we're looking at the left. So that idea that we're able to convey is going to be that when we're looking at a print like this one, we're going to be able to see this is a front, a right, and a top. Generally what we're going to be seeing is we're going to be seeing a right side view down in this left-hand corner, this lower left-hand corner, excuse me, the front view on this lower left-hand corner. And then we're going to see the right view to the right of it, and it's going to be moved just like that. And then the top. I like to be able to say that when I'm looking at something, I want to be able to grab a hold of it, turn it around in my brain, and being able to come up with this 3D image to figure out what I'm looking at. It'll be the same with this first assignment. Here we only have two views, but it's simple enough. We only have two parts. We have this part here, this base, that we're making this T-joint out of, and then this vertical member. We can take a hold of that, we can flip it around, and we can see just exactly what we're after. We're looking at a part, if we're looking at piece parts, we're looking at 4 by 6 for this one. And we're looking at 2, and it looks like it's the same length by 6 for this vertical member. Okay? So we're just going to start with that. I'm going to start with those lines. These object lines. A thick solid line to show the visible shape of a part or outline of an object. Hidden lines, we'll get to hidden lines. These are broken lines of medium thickness. And we're talking thickness or solid. We're talking about how heavy we're going to be pressing into our graph paper. And if you've gone out and you've bought these mechanical pencils, you've probably noticed different diameters and stuff. You can use different ones. Just for our class, you can just pick one size. We're not going to get too in depth into it. The thick solid line to show a visible shape of a part or outline of an object. Hidden lines, either is a broken line of medium thickness to show edges and outlines not visible to the eye. So if we were to look at this and we're to look at this line here, if we were looking at the back side, we would see a dashed line about yay, right? And it's going to be in line with that to tell us that there's a hidden line right in here. I don't know if that camera's picking that up at all. Here we go. Yeah, so that would be a dashed line. A center line. This is a fine or broken line made up of a series of short and long dashes alternately spaced to show the center of circles, arcs, and symmetrical objects to aid in dimensioning these parts. We'll look at the example at the back of the chapter here shortly. Okay. What we're going to be seeing a lot of, object lines that trace out the outline of the object. We're going to see a lot of these extension lines and dimension lines. Extension lines are fine lines that extend from the object with a slight break between. We're looking at the homework. You see there's going to be just a little gap in between here that runs along the plane of the part, but it's broken there, and then along the line it tells us what these are. This guy probably ought to be opened up. So anyway, they have little breaks here, extend off the plane that we're looking to dimension. Extension lines show dimension points. Dimension lines touch the extension lines and show distance given by dimensions. See dimensions line or fine lines with arrowheads, the little arrowheads where they're touching, unbroken except where the dimension is placed. Sometimes we'll see dimensions written above this dimension lines, and sometimes we'll see them written right through the middle of them. A leader, a fine straight line with an arrowhead or a round solid dot at one end. It is usually drawn at an angle. Points directly to a surface for the purpose of dimensioning or adding a note. A dot is used at the end of a straight line where reference is made to the surface area. We'll see a lot of these pointing right onto the surface and not to the edge. So if, for an example, you see something like this. It'd be an arrow or a circle. It wouldn't be to the edge, it would be on the surface of it. And a note, Legos. Alright. If you happen to have one of these, fantastic. These are great little tools. Use them in the shop for doing layout or for what we're doing here for blueprint. As I mentioned in class, you can pick up some pretty cheap plastic stuff at any office supply store. These are nice also. You know, take them out on the floor with you. Anyway, back to it. Okay. Cutting plane. Now this is for if we want to, what these are for is if I want to take a section view. Say I wanted to cut this away. I want to be able to make this, it says a preferred cutting plane line is heavy broken line made up of a series of one long and two short dashes alternately spaced. That's that guy there. Arrowheads are placed at right angles to the cutting plane as shown. Alternate cutting plane lines are a solid heavy line or a series of long dashes. What this is for is to indicate where an imaginary cut is made through an object. The arrow points in the direction in which the section should be viewed. Letters next to the arrowheads identify the section in cases where more than one section is shown on the drawing. To give you an idea of that, I'm going to look at it like this. You cut through it. Oops, that wasn't very straight. So what we see is we're taking a cut, and the arrow is showing the direction that we're going to be looking. And if we were to take that cutaway view, we'd put that cutaway view, we call this like a section view, and we're going to give it a designation of A. And you'll see we'll see somewhere on that print or on another page and a section view page, and what we'll be looking at essentially is a right side view from here forward. It doesn't include this, it's just this part. We're just putting a slice through there and looking at it from the right side. So it would look very much like this right side view, but we'd be able to see whatever the makeup is of it, and you have these section lines that give you an idea of what the material might be made of. We might see something like this where whatever our Lego dimension or section line would look like, that's what we would give it. Okay, let's move on to these chain lines. Heavy broken line made up of a series of long and short dashes alternately spaced and indicates a location or extent of a surface area. Short break lines are heavy irregular lines drawn freehand. It's to show a break, to conserve space, and a drawing to show a partial section. Same with the long break line. These are ruled light line with freehand zigzags to show a long break to conserve space on a drawing. Say we have something that's really long, but we don't have enough space on there. We'll give this break line in it. Come down, give it a little jog. Come down, give it a little jog, and that's just saying that we've just removed a section of this so that we can fit it all on here. If we have 100 feet of pipe and we have two flanges on the end, and I want to show the detail of those flanges, I'm not going to put 100 feet worth of material on the paperwork. I just want to show you the details that I need you to know. So that's why we would use something like that. Phantom lines. Lines broken, line made up of a series of one long and two short to show alternate positions of a part, to show a relationship of existing parts to new part, to show machine surfaces. Okay. Back to here. What we're seeing here at the top on this pictorial representation, this gives us a good idea of what we're seeing if we don't have an orthographic view. Oftentimes we're going to see either an oblique, which we're going to see a 90-degree face. So if we cover this up, we just see this just as we would at 90 degrees, and this oblique will be moving away from us, right or left. This pictorial one though is at 30 degrees. We see that representation a little bit more like that than we would like this. Let's see, oblique, something like that. If I can get it in frame. This isometric, we're not going to use this one so much. I like seeing it on the drawings, but we're not going to be doing any of those because the isometric paper has added these 30-degree lines, and it gets pretty busy. I mean, you can tell just from our first one that we're looking at, there's plenty there. We don't need to add too much more to the drawings that we're going to be doing. So we're just going to stick with the 1/4 inch square graph paper for now. It should be noted that the front view usually gives the best indication of the shape and detail of the object. It does not mean that the front view necessarily shows the front of the object. The profile selected for the front view is generally that which best describes the most detailed shape of the object. All views have a particular position with respect to each other and have either a horizontal or vertical alignment. That horizontal and vertical alignment is pretty important. And we can see, if we're looking at a horizontal alignment on this example, as we're looking at our part and we're moving it this direction, we can see this horizontal alignment where this surface lines up here, okay? And we can see that on this vertical that this surface, this plane, is in line with that one. There's that line there and there, giving you a good visual representation. Okay, we're going to have a look at some of our examples. If you've never seen one of these before, this can look pretty busy, but we can break it down. So we know that these solid lines are going to be representation of the part, and we know that these dashed lines from the reading are going to be a hidden line. We can know that these alternating lines are going to be telling us that it's a hidden line, and this long and short and long is going to be the center line of our part. So we can see we've got a front, a top, and a right side. So we've got that nailed down. We've got a front, a top, and a right. So if we take this front, we can rotate it, right? We're rotating it inside there. We've got our front to the top. We're looking at what this represents is this circle. If we want to see that circle over here, we see it again as we turn it from the front to the right side. There's that circle again. And here's these long and short dashed lines representing the center line of that hole. We know it's a hole because we've got a note right here that says, see this circle right here, it has a circle with a slash going through it. That represents diameter. We're looking at a 1. We're assuming that it's an inch. Looks like we're measuring an inch, 1 inch diameter hole to be drilled through that part. And where did we locate that part? Well, we've got these dimensions, and we have these extension lines. Here we've got the extension line coming off of the edge here, 3 inches in from this edge to the center line. And here's in our other dimension, we've got one axis, then we go looking for the other. from this extension line off of this plane to the center line, we have 1 inch. So we know that the dimension of this hole is going to be 3 and 1 to the center line, drilled to 1 inch in diameter. If we're looking at this at just one piece at a time, this part that we're drilling this hole in, we can see that this part is 4 inches this direction here by, not that one, if this is 4, okay, if this is 6 and this is 1 inch in, we know that this is a 5 inch dimension from along the face of that. So we have 4 by 5. See, if we have this as 6 and we've come in 1 inch, we know this is 5 inches. This part here, I believe we're calling it Q. 4 by 5, and we can have, look here, we have a dimension of 1/2 inch here for thickness. It looks like it's going to be the same for that part there also. So this piece that was on the very top, we're calling our top part, 4 by 6 by 4 by 5, 1/2 inch thick. Looking at the bottom part, this part that we see, this dash line, is this part that's hidden underneath here. This dash line is a representation. This is a representation of this solid line here where it disappears. You dash, 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 dash. Lets us know that it's sitting underneath that part. It is 6 by 2, 1/2 inch thick, 6 this direction from hither to yon, by 2 inches here to there. No problem. We start breaking it down once we understand what we need is we're looking at an orthographic projection, a front, a top, and a right side view. You can see that we have a diameter. You can see that we have that gives us a note on what we're going to do with that. Yeah, that's not too bad, huh? Not too bad. Yeah, there's our note there. That symbol there is used to denote diameter. Here, over here, what we have is an engineering block or a title block. You can see what it's called. We're calling this a jig support. We have a drawing number, a date, a scale, a half an inch equals 1 inch. So for every 1/2 inch, we have an actual 1 inch. So let's see if this is 6 inches. Let's see if it actually came out. 3. There we go. So if every 1/2 inch is 1 inch, then for every 1 inch we have 2, so that's 6 inches. All right. We want to make sure that our scale is right because we're going to be writing down here a visual representation of what the final part or assembly is going to be. And if we don't have our scale right, if this is 6 inches, we stretch this way out here to 6, and our 1/2 inch is this, and our 4 inches is just really small. We don't get the scale right, and when we go to put our assembly together, we can look at it and go, man, that is not a good visual representation of what I got going on in my paperwork here. So you want to make sure that that's why scale is important. For us, for our example here with the Legos, we got 2.5 by, looks like 2 1/8. Using 1/4 inch squares, I'm going to go to the nearest square just to be able to keep these lines nice and clean. It doesn't have to be perfect, but it has to be pretty close so that when you get it built, it's a good representation of what you're actually making. So and on this first assignment we're doing, these look pretty thick. We're going to be making these out of 10 gauge material, but if we were to have a 10 gauge representation on this, it would be pretty thin, and we'd be looking on edge. We wouldn't be able to get a good idea of what it is. So when we do something like that, where we're working with thinner materials, or if if our dimensions are really close but we're not quite there, and we need to make that little extra adjustment, we can add a bit of thickness to it so that we can see it. We come to the nearest, just to keep the prints clean, just so we can get close. We don't have to be perfect, but we want to be close to scale as we can. Anyway, back to this title. I want to go back to this title block. Title block or engineering block. Jig support, drawn by Lindsay Grady. She wants a total of 25 of them. Shop order number 8. Yeah, no problem. We can knock those out. Let's look at another one. All right. This one's got some good representation. So we know that we're looking at an orthographic view. For here in the lower left, we've got our front. Next to it here, we have our right side. Then we have our top. Here we're looking at this V groove test block. This block is made up of this nice rectangular shape. We've got some hidden lines here. What is that hidden line telling us? If we're looking over here at this hidden line, and remember we're looking to make sure that this horizontal indication matches up. So this dashed line is the bottom of that. If we were to turn it up, that dashed line is at the bottom of this V right there. Okay. If we're looking vertically, we can see that this is in line here, as it should be. The bottom of that's in line with that to tell us that's the bottom of the groove. We've got a nice pictorial representation right here. This one's fairly simple, no extension lines, no dimensions. That's a good example. Anyway, what we're going to do, and we'll talk about it in class if I haven't already. This is the assignment for the week for Friday. What we're going to do is we're going to do a little pad buildup, and this is our welding symbol for a pad buildup. It looks kind of not exactly what we're after, but what we want is a pad buildup on the bottom, and we want fillet weld. This is a symbol for fillet weld. And we talk just a little bit about these lines. On these welding symbol lines, this here is a reference line. From where it breaks away, this is going to be an indication of where that weld's supposed to go. You see there's two triangles. There's one on the bottom and one on the top. If it has an indication of what it wants, it's going to be on the bottom. That's the arrow side. That's the side that the arrow is pointing to. If it's on the top of the reference line, that is the other side. So what this is asking for, and this is a symbol for the fillet weld. It's going to be a vertical member. It's always the vertical member of this triangle is always on the left, and then goes to the right, this direction. This is our symbol for a fillet weld. For the arrow side, that's the bottom. Arrow side sits here. This one for the fillet weld for the other side. Arrow side. Other side is going to be right in here. So that's going to tell us that we want a fillet weld right there. The way I like to explain how to know which one's the other side is if this arrow is pointing and it says that it's on the other side, we're going to dive down beneath this surface. This surface, by the way, is called the faying surface. The faying surface, where these two parts meet together. You dive down underneath that faying surface, and that's where that other side weld's going to be. This is going to be, you got a 10 gauge material. So while you're practicing this week on your competencies, and we're going through the sign-offs, and we'll check those off, I want you to work on your pad buildup, and we're going to be cutting out some material on the iron worker. If you haven't already been checked off on the iron worker by myself or by Harvey, get with us. We'll show you how to operate it, and we're going to have you cutting some 10 gauge material. And this first one we're going to see for the bottom part is 4 inches by 6 inches, and for this vertical member it's going to be 2 inches by 6 inches. So that's going to be what we're going to do in the lab. What I'm going to have you do for blueprint is I'm going to have you do the piece part drawings for these two parts. What I'm going to be requiring is that you have these nice lines on graph paper, on your 1/4 inch graph paper. That you use some dimensioning lines, or excuse me, some extension lines and dimensioning lines. And you don't have to go all out like this. This is a little too much. Just 2 and 2 for inches, 6, etc., etc. We don't have to go that far out. We're not going to get that. We're not going to get that critical as far as our dimensions. So I'll do one with you right now. Maybe. There we go. And I'm not going to need to see an orthographic view for these piece parts, so I don't need a front to top and a right for the piece parts. Just to make it easy, we're just going to do one piece. So let's start with this. Let's start with this bottom one. This one that's 4 by 6, and we're going to do it to a 1-to-1 scale. So that means 6 inches is 6 inches, and 4 is going to be 4. So find a place for your 0. This being 6 inch. I'm starting with 0 there. And go all the way to 6 inches. Now, we're asking that it's 10 gauge material. If we go 10 gauge and we do it 1-to-1, that's going to be pretty small. So for the sake of making this easy to see, we're going to just going to go to the nearest line. So we've got 6 inches. Oops. I like to break one square away. I come down about 2. Oh, you know what? Let's just do 1. Let's just do 1. I was going to put 2 on there. We're going to go 4 inches up this way. 1, 2, 3, 4. And 6 inches across. 1 view's plenty. We don't need 2. Again, I like to give it a space of 1 and then go 1, 2. About halfway in the middle, we've got 3 inches. We're going to give it our 6 inches. Okay, so we've got our extension lines. And we've got our dimension lines with the dimension of 6 inches. We'll do the same out here. Let's clean this up. We're going to skip this line, this first square. We're going to go 2. Skip the first one. We'll go 2. Halfway between 4 is 2 inches. 1, 2. We're going to go. We say that was 4 by 6. check. There we go. There we go. Look at that. Piece of cake, huh? We're going to give it a note also to say what this is. You can give it an arrow, you can give it a little circle. You can say 10 gauge, that's the thickness of the material. 10 GA, mild steel. So I'm going to ask of you as you give me two of these, make sure that you have your name on it. One's going to be the bottom part, one's going to be the top part. Staple them together and hand them in. And then Friday in the lab, I'll come around and collect these. It'll be 4x6, 2x6 pad build up on the bottom, fillet weld on the arrow side, that's the bottom, and a fillet weld on the other side, that's the top. Those fillet welds, we want to make sure that those are going to be size appropriate. Size appropriate means it's going to be size of the thickness of the material for each leg. And we've talked about the leg in class, the leg being from the bottom right at the joint to the top at the toe. Be about 10 gauge. That's about 1/8 of an inch. 1/8 inch weld here, 8 from here to there, here to there. All right. If you have any questions, let me know. That'll be about it. Oh, yep. Tolerances. Tolerance is going to be plus or minus on all measurements. So your dimensions on your piece parts, if they're 1/16 too large or too small, that's okay. That will be within tolerance. And the same for the location. Here we see the location for the part, and it's going to be 3/4 of an inch from this end in, plus or minus 1/16. Make sure that you note the location of where that line is so that you're not putting the part on the wrong side of the line. That's important. So it's going to be 3/4 of an inch to this face of that part. Okay, I think that's it. If there are any questions, please let me know.